from the previous lecture that the distance matrix is a set of all dependent distances. And since it's really a set, we can reorder the rows of D. I mean the distance matrix. And also, unimodular transformations require that all dependencies are uniform, which means they must have known constants. What is interesting now is to determine which transformations are valid. If we take a distance vector or dependence vector with the known constants d, then in the transformed loop using the k variables, the distance vector will be this instead. Since we compute the k from the original index variables and the transformation matrix. So this dependence vector is transformed into this one. And the new distance matrix becomes this for the new, and LU is the transformed loop. Okay, what can we say about this matrix? Can it look like anything, or are there certain rules? There certainly are certain rules, namely that if we look at each distance vector, the first non-zero element must be positive. If we would have a negative first non-zero, it would mean that an iteration depends on a future iteration. So this one is invalid. We can never get, well, if we will compute the transformation matrix so that this never happens. But it may be a good idea or to check that the transformation matrix that we produce actually never has a negative first non-zero row as a check, consistency check of the compiler. Okay?